Hello class and welcome to Iotaclasses 1729, making learning easy. In our series of lecture, we have completed various aspects of physics such as motion, okay, and the force and laws of motion theory is also completed. On the other hand, we are also starting the classes on algebra. So please subscribe the channel and press the bell icon so that I get motivated to present my videos. In this session, we will talk about the 10 questions on motion, force and laws of motion. Okay, these 10 questions will be very much helpful for your examination as far as your NTSC and other competitive exam is concerned, your board exams is concerned. Okay, so we will solve these 10 questions which are important as related to your exam. So let's start the video. Okay, as I told, we in today's session we will see question based on motion and laws of motion. So yes, again we have covered these things. Okay, you can see that. So please subscribe the channel, press the bell icon. Okay, the first question comes here: the action and reaction forces involved in Newton's third law. Okay, this is the question: the action and reaction forces involved in Newton's third law. The first option gives it must act on the same object. The second option is given must act on the different objects. The third option is may act on different objects, and the fourth option is none of the above. It is very much obvious, okay, that when an object, okay, imparts a force, okay, so that is your action. Okay, this is your action. Okay, this action is on this object. Okay, and the reaction that will this object will give you on the first object. Okay, so the action and reaction, okay, action and reaction cannot act on the same object. Okay, and if it act on the same object, then the same question we'll see in the next in the same today's session. But for a general case, okay, that cannot act on the same object. Okay, that must act on the different object, because action is by first object on the second object, and the reaction is by the second object on the third object. Okay, so this must act on the different objects. So option B is correct. Let's move ahead. A long jumper runs before jumping to take a long jump because he covers a great distance, he maintains momentum conservation, he gains energy by running, or he gains momentum. Okay, so obviously, okay, option number D is correct. He gains momentum. Okay, by running, okay, his velocity increases. Okay, his velocity. Okay, he gains velocity, and by gaining the velocity, okay, uh, he can have a good momentum. He can have good momentum. Okay, to jump. Okay, to jump. So option number D is correct. He gains momentum. Okay. Which of which one is the measure of inertia of body? Very basic question. Okay, asked in examination. So mass is your measure of inertia. Okay, mass of a body is the measure of inertia. Okay, this is related to Newton's first law of motion. If action and reaction is to act upon the same body or object, then okay, now this is the case that I told you. Okay, for the first question. Okay, if the action and reaction act on the same object, then let's say this is your force of action, and this is your force of reaction Fr. So this resultant force would be okay, this action force is equals to reaction force, and if you bring this quantity in this side, okay, so your of Fa minus Fr would be 0. Okay, so your resultant force would be 0. That is correct option. Okay, that is correct option. And as the resultant force is 0, okay, the body will not move. Okay, because the resultant force acting on the object will be 0, and no net force will be acting. Okay, and hence both the option A and B are correct. Okay, this is the answer of this question. C is your answer. Okay, C is your correct option. Which of the following is incorrect? 1 kg weight is 9.8 Newton. Okay, that is correct. Momentum is a vector quantity. That is also correct. Force is also always conserved. No, this is wrong. Moment is conserved in the absence of external force. Momentum is conserved in the absence of external force. This is also correct. So force is always conserved. Okay, this is wrong. This is incorrect statement. Okay, for forces such as frictional force, okay, such as air resistance, okay, it does not depend on the path, okay, it is in conservative forces, okay, such as frictional forces, such as air resistance forces, all that other forces are in non-conservative forces, okay. And as far as conservative forces, gravitational force, okay, spring force, all that are conservative forces. So option C is correct here. Force is always conserved, that is a wrong option. Rate of change of momentum gives, very simple, okay, rate of change of momentum, okay, that will give you force, okay. Rate of change of momentum is nothing, okay, that is dp by dt, okay, dp divided by dt. And what is this dp? P is kg meter per second and time is again second, so this will give you a kg meter per second square, and this is your force, okay. So correct option is your force. Option number B is correct. Question number 7. A ball of mass 150 grams starts moving with an acceleration of 20 meter per second square. When hit by a force which acts on it for 0.1 second, the impulse force is, okay, very simple question. Impulsive force they are asking, okay. Impulse delta is equals to force multiplied by time, okay. Force is equals to mass into acceleration, okay, multiplied by time, okay. Mass is given to be 150 gram, so convert it into kg divided by 1000. Acceleration is given 20 meter per second square, okay, that is again SI unit, and this is your 0.1 second, okay. 0.1 I can write it as 1 divided by 10, okay. So this was 0 gone, okay, this again 0 gone, okay, and this is uh, 2 into 150, that is 3000, sorry, 300 divided by 1000. So this is 0.3 Newton second. So this is your correct option, okay. Option C is your correct answer, 0.3 Newton second. This is your impulsive force. Match the following Newton's first law, second law, third law, and impulse. Here are given change in linear momentum, action and reaction, law of inertia, and force equals to mass is equals to. For this option, okay, for first law of motion, that is your law of inertia. So this is your A. Okay. Newton's second law of motion, obviously force equals to mass into acceleration. That is your Newton's second law of motion. Third law of motion is your, okay, action and reaction, okay, that is related to Newton's third law of motion. And impulse is this change in momentum, change in linear momentum, that is your D, okay. This is the matching the following, okay. This is very simple question. This is the match the following, okay. So this answers I have written in front of the option 1 2 3 4. A force of 5 Newton, okay, gives a mass m1 and acceleration of 8 meter per second square, and a mass m2 and acceleration 24 meter per second square. What acceleration would it give if both masses are tied together, okay. So here, okay, we know that force equals to mass into acceleration. Force is going to be 5 Newton, we don't know mass m1, acceleration is 8, so from here m1 is equals to 5 by 8, okay, this is your option, equation 1. Again your force F is going to be mass m2 into acceleration, okay. We know force 5, m2 we don't know, and acceleration is 24, so from here, okay, m2 is equals to 5 upon 24, okay, this is equation number 2. So adding these two equations, okay, m1 and m2, what we will get? 5 divided by 8 plus 5 divided by 24. I can write this as 15 divided by 24, and this will fetch me, okay, 20 divided by 24. This is my total mass, okay, m total. So now I want acceleration, okay. So again, force is equals to m total into acceleration. I know this is force is 5, 20 divided by 24 into acceleration, okay. 20 4 za 4 6 za, and my acceleration turned out to be 6 meter per second square. So answer B is correct, okay, 6 meter per second square. Just find out the individual masses, add them, and find the resultant acceleration. And the final question, the second hand of a watch is 2 centimeter long, the speed of tip of the second. This is your homework, okay, this is your homework. So try this question, and we will see this question in next session. The solution of this question I will give in next session. Okay, till then, okay, thanks for watching. Please subscribe the channel, press the bell icon, and we'll again back with the next new video. So thank you very much.